Peter Jackson isn't directing Jurassic World, Rebirth, but he may help make it real. The Oscar-winning filmmaker behind The Lord of the Rings has officially joined forces with Colossal Biosciences and the Ngai Tahu Research Center on an ambitious real-world mission to bring back the South Island giant moa, a flightless bird that once stood over 12 feet tall and vanished from New Zealand nearly 600 years ago. The moa, which lived alongside Maori ancestors in Aotearoa, is the centerpiece of a first-of-its-kind indigenous-directed de-extinction project that blends cutting-edge science with traditional Maori knowledge. To learn more, we spoke with Peter Jackson, alongside Colossal CEO Ben Lamb and Ngai Tahu archaeologist Kyle Davis, who shared with Screen Rant the behind-the-scenes story and what comes next. So, my partner Fran and I said to Ben on that first call that we will invest in the company so long as you spend our money on the MOA. Jackson laughs. That was the deal, really. We had just spoken with Ben Lamb after the Jurassic World Rebirth premiere to gauge his thoughts on the franchise's evolving depiction of de-extinction, and weeks earlier also met with him to discuss how Colossal Biosciences is working to bring back the dire wolf. For this conversation, however, we were looking at the beginning of something new that directly involves a filmmaker and is leading to a significant expansion to Colossal's physical laboratories. Jackson tells us he was introduced to Colossal by fellow filmmaker Michael Dougherty, who was already secretly working with and documenting the company's work on species like the woolly mouse. But Jackson's interest was specific and personal. Jackson and his partner Fran Walsh offered to invest, on the condition that the company commit to a MOA revival. Now, that idea is becoming a reality. Ben Lamb lights up when talking about the science already underway. He tells us that sampling began in late 2024 using Jackson and Walsh's own collection of 300 to 400 MOA bones and what's available at Canterbury Museum. And we're already doing sequencing, which is great, adds Lamb. The next year is also hunting for MOA bone, Jackson adds. Because while we had 400 bones, only 25 of them were deemed viable for DNA. They have to be dense and heavy, they can't be lightweight. And of those 25, only 2 of the samples provided a viable genome. There was a stout-legged moa and a little bush moa. Because of our bones, we've got all 9 species in our collection, but out of 400 bones, only 2 are viable for DNA. That's the strike rate. Colossal is now building complete reference genomes, not just for the giant moa, but all 9 extinct moa species, Lamb explained to us. Their work includes a breeding colony of tinnimus, studying emus, and developing primordial germ cells, which are critical tools for synthetic reproduction. The tinnimus, Lamb tells us, could very well be how the giant moa can be bred once engineered. While the moa might seem like an ancient relic from the dinosaur age, scientists say that's not quite true. I reached out to evolutionary biologist Professor Matthew Phillips, whose research shows that giant flightless birds like the moa, ostrich, and emu didn't all evolve from one big grounded ancestor. Instead, their flying ancestors likely spread to different parts of the world and then lost the ability to fly over time. In other words, the moa was a unique product of evolution in New Zealand, not a leftover from some ancient era. It only went extinct centuries ago. While the lab work unfolds, another critical question looms. Where would a resurrected moa actually live if this project succeeds? Colossal Biosciences has emphasized rewilding as a core part of its conservation mission. This refers to the long-term goal of returning de-extinct species to their natural habitats, including the widely discussed project to bring back the woolly mammoth to the Arctic tundra. For the MOA project, that means not just bringing a bird back to life in a lab, but eventually restoring it to the wild in a way that supports healthy ecosystems and biodiversity. A 2024 study referred to me by Phillips and published in Nature, Ecology, and Evolution offers important clues. Researchers found that as moa populations declined due to early human activity, the final survivors clustered in cold, mountainous areas that acted as ecological refuges. These were remote and less disturbed habitats where the birds persisted the longest.